In this video, I'm going to show you some examples on how to combine different logs, many logs, into a single log, but they must have the same base, okay? And also, we will talk about how do we solve equations that have logs, okay? So first of all, let us learn how to combine more than one logs into one log, okay? Look at here, there is 3 log x with base a plus log x plus 3 with base a minus 2 log x plus 1 with base a. All of them have the same base a, meaning we can combine them into a single log. Now we will use the formula. We have the log of the sum formula, log of the difference formula, and also we have the base change formula, power formula, and everything, okay? So before we combine more than one logs, the log must be free from the coefficient. There must not be a number. So on the second log, there is no number. On the first log, there is a number. But we know that that number can be moved to the exponent here, right? And also that number can be moved into the exponent here. So if you do that, what you get is log of base a x to the 3 plus log of base a, there is x plus 3 minus log of base a x plus 1 to the 2. That's what happens. Okay, now what is the log of the sum? So sum of the logs here, right? Log of x plus log of y, it's like that form. So it is the product, right? So you can do those two first. So just write a single log, and then if there is a sum of the log, you multiply the product of those two quantities, right? So it will be x cubed times x plus 3. That's the sum formula. And then minus log of base a x plus 1 to the square. Now you combine those two log too, but what is the formula for the difference of log? Difference of log is the quotient, right? So what you write is you write a single log with base a, you write that on the top like x cubed x plus 3, x cubed times x plus 3 divided by x plus 1 square. That is the difference formula, right? That is the final answer. So this is in the form of a single log. There were 3 logs. What we did, we moved any number before the log to the exponent, and then now all these logs are free from coefficient. Now we use the sum rule for the first and second log. We got multiplication there, right? And after you do that, you copied the third log as it is. Now you combine those two logs. So how do you do that is, there is a minus, meaning log x minus log y. It's like log a minus log b. In that case, it will be log a divided by b. It's like log this divided by that term, right? That's the final answer. Now let us do this exactly the same thing here. So there is 1/2. There is no number in this log. There is a number in this log. There is no number in this log, okay? How do I do that? Is you move that to the exponent here. What you get is equals log base a x to the 1/2. Do you know what is the meaning of x to the 1/2? It is root x, right? There is root x as well. This has positive sign, this has a negative sign. You can cancel that. So we will do that, but let us write down the other log of 3x. The base is a plus, I want to move this to the exponent 2 as I did here, okay? So log of x to the 2 with the base a minus, this is same as log of x to the 1/2, or you can keep root x and then cancel that. So what cancel out is, this is log of x to the 1/2 positive, this is log of x to the 1/2 negative sign, so they cancel out. So what is left is these two terms, okay? So what I want to do on those two terms is, I want to write the positive term first, log of x squared with base a, and then minus log of 3x with base a. Now look at that, they have the same base and there is no number before the log, meaning there is no coefficient of log. So you can combine into a single log. How do you combine that into a single log? Is basically you write the first one and then divide by the second one. It will be x squared over 3x. You see that? This is what you get. So if you simplify, there is x times x, you cancel one x with the other x. So basically the final answer, I should not forget base, is log base a x over 3. That is the final answer, because this is x squared means x times x, and this is 3 times x, so you cancel x, you divide x by x is 1, so x over 3 is left. So this is the final answer. All right. So in example 3, 4 and 5, we are going to solve logarithmic equation, meaning you have log in the equation and you want to solve for x. Okay, that's the logarithmic equation. Now look at here. So this log has 4 as a coefficient. This log has negative, or you can think of -1 as the coefficient. Okay, so how do you equate those logs? Is basically what I want to do is I want to write this log free from x. I want to write this log free from x. So how do I write that? Is I would write log of x to the 4 with base 3 equals to, I want to move this negative sign to the exponent. So it is log of 81 to the -1 base is 3. Now see, you see that there is log without any number before log, meaning without any coefficient. This log also without any coefficient. You can think of like cancelling this log and that log, but actually what happens is if log x equals to log y with the same base, then you can write x equals to y. So basically you can write this implies x to the 4th equals to 81 to the -1. But what is 81 to the -1? 81 to the -1 is same as 1 over 81, right? So it is x to the 4 equals to 1 over 81. Okay, so how can you write this as the, how do you solve this? Is basically you want to try writing 1 over 81 as the exponent 4. What raised to 4 is 81? 3 raised to 4 is 81. There is 1 in the top. So you can write x to the 4 equals to 1 over 3 to the 4 as well, because 1 to the 4 is 1 and 3 to the 4 is 81. Now you just equate the exponent. So what you get is x equals to 1/3. Now, so one of the things that I wanted to mention here is you can think of plus and minus sign here. Plus and minus sign. So if you take positive 1/3 to the 4, if you raise positive 1/3 to the 4, you get 1 over 81. If you raise negative 1/3 to the 4, you will get 1 over 81 as well. But if you take both positive and negative, you will get positive and negative here, right? But which one is the answer and which one is not? If you take x equals to -1/3, then and plug in here, will give you log of negative. So log is not defined for the negative values. So we ignore actually the negative value. So the final answer is x equals to 1 over 3. That is the final answer. Okay. Let us do example number 4. So the good thing here is the left side logs are free from coefficients. So they are ready to combine. So you can write log base 2. How much is that? Is x plus 7 times x plus 8 equals to 1. If you simplify, what do you get? Log of base 2, this is x squared plus, if you FOIL this, you will get 15x plus 56 equals to 1. Okay, so what you get is I want to get rid of log because there is only one log here. I want to get it. How do I get it? It is like base to the other side is basically you can write x squared plus 15x plus 56 equals to 2 to the 1 is just 2. Now since this is a quadratic equation, let's subtract 2 from both sides and make the right side 0. You'll get x squared plus 15x plus 54 equals to 0. Okay, because that will cancel out. Now, can you get two numbers whose sum is 15 and the product is 54? So let's write down that sum is 15, product is 54. Will be plus 9 and then plus 6. 9 plus 6 is 15. 9 times 6 is 54. So it looks like if you solve the first one, you will get x plus 9 equals to 0. That implies x equals to -9. And then if you solve the another one, x plus 6 equals to 0, you will get x equals to -6. But as in the radical equation or the equation involving roots, after you find out the answers, you will have to plug in to the original question and then see which value works. Okay. Since the both x values are negative, we will have to check here. Here in this case we did not check because we knew that x equals to 1/3 is positive and log is defined for the positive. Now let us plug in x equals to -9. Does this make sense? Log base 2, -9 plus 7, you will get negative number here, also negative number here. So log is not defined for negative number, so -9 does not make sense. Okay, let's check -6. -6 plus 7 is positive number. -6 plus 8 is positive number. So it is the final answer. So final answer is x equals to -6. So the important thing that you should not forget when you solve a logarithmic equation is after you find out the final answer or the solution of x, you need to plug in back to the original question and then see if both or each of the value of x makes sense in the original question. So in the example 4, only one value was making sense and the other is not making sense. In example 3 also we got two values but only the positive makes sense. So we keep the positive one and ignore the negative one. Let us do the last example. So here there is one log in the left side, there is one log on the right side. Let us combine those two, bringing this to the left side. How do you do that? Is add plus log base 4 x plus 13. Let's do that way. So what you get is log base 4 x plus 1 plus log base 4 x plus 13 equals to 3, because that cancel out, right? Now you combine those two because these two logs are free from the coefficient, so you can combine with the one log, so it will be x plus 1 and then x plus 13 equals to 3. Okay, now how do you get rid of that log? You will get x plus 1 x plus 13. There is only one log, so is base to the other side is 4 to the third. Now let us FOIL the left side. You will get x squared plus 14x plus 13 equals to 4 to the third is 64, right? Let me subtract 64 from both sides. What you get is x squared plus 14x minus, is that 51 equals to 0? Now we need to get two factors for this because there is 0 on the right hand side. So x and then x equals to 0. So what are the two numbers whose sum is 14, product is -51? That will be plus 17 and then minus 3. See, the sum is positive 14 and the product is -51. So now you solve this. X plus 17 equals to 0 implies x equals -17. Similarly, x plus 3 equals to 0 implies x equals to -3. Sorry, x minus 3. Okay, x minus 3 equals to 0 implies x equals to +3. Now, is x equals -17 works for this for the given question? The answer is no, because if you take -17 here, you will get log of -16, right? Because -17 plus 1 is -16. So log is not defined for the negative value. So this is not the right answer. How about +3? Log of 3 plus 1, that works. Log of 3 plus 13, that also works. So that means this is the only final answer that works for the given question. Okay guys, thank you very much.